Okay, some of the rules of perspective, one-point perspective drawing, which is the simplest form of perspective, are that you have the vertical and horizontal lines are parallel to the edges of the picture plane, right? So this most perspective drawing is the easiest to understand when we set a bunch of boxes into a space and we place them all parallel to each other, and by doing so they follow all the same rules. So the vertical and horizontal lines are parallel and perpendicular to the edges of your sheet of paper, your picture plane, and the horizontal lines are parallel to the horizon. The diagonal lines converge towards a vanishing point on the horizon. And even this box that's floating up in the sky behaves the same way because it's been set into this space with its edges parallel to the other boxes. All right. In this image, it's very similar to the previous one. However, there's a couple boxes that are sitting in front of the horizon line, so again, you don't see the tops or the bottoms. Theoretically, one could keep adding boxes, and you could just fill an image with these objects that all converge into space, and it definitely creates this illusion of depth. This appears to be kind of looking down on an urban center, and it has this definitely a feeling of depth, but there are some limitations in how realistic this is, which we'll get into in the next few slides. Okay. Here is a example of a bedroom drawn in one-point perspective. You have horizontal lines that are all relative or parallel to the horizon line, and then all the verticals are perpendicular to the horizon line or parallel to the right and left sides of the image, and then all the diagonals are converging at a point in the center. The vanishing point does not have to be in the dead center of the image. So if you were to extend those diagonal lines coming off the table and the room and the furniture, they would end up at a point somewhere around here, right? Maybe over there. And so in this image, it's been offset, but this still follows the rules of one-point perspective because all these the verticals and horizontal lines are parallel and perpendicular to the edges of the picture plane, which in architectural drafting we call those orthographic lines, and the diagonals all converge to a single vanishing point on the horizon line beyond this wall. Going back to the School of Athens, if we were to map out all those diagonals, they converge at a point in the center, which makes this, which helps to draw our eye around the image and keep coming back to the center where we have these philosophers discussing the nature of reality. In two-point perspective, boxes are typically placed on a tilt so that we are looking at a corner as opposed to a face. And the verticals are still oriented up and down orthographically, so they are parallel to each other on the image, but now you have two sets of diagonal lines that are going to vanishing point over here and vanishing point over there. And when you have a box oriented in the air above the horizon line, it still behaves the same way. But this all works when these boxes have been placed in a space that are parallel to each other. So if you were to put another box somewhere here and you were to tilt it a little bit so that its edges are not parallel to the other ones, then it would create two new sets of vanishing points, but it'd still be 2-point perspective. All right, this is an example of 2-point perspective when it's been exaggerated, because the boxes up here and down here are fairly far away from the horizon line, but the vanishing points are quite close. So while this one looks relatively normal, the one that's above it and below it are kind of distorted. And I show this to students so that they understand how this system kind of breaks down. I mean, it looks kind of dynamic, but in the real world, you'd never see a box actually oriented like this with such a sharp corner, and then the edges are straight up and down. So to correct this drawing and to make it appear a little bit more realistically, I would suggest taking the vanishing points and moving them farther out there and farther out there, which would make these corners a little bit less extremely distorted. Here's a sketch I did of New York City in 2002. I sat on the street and sketched the Flatiron Building, which is this famous building from the Art Deco period of design and architecture, and the Flatiron. And it's situated on Broadway, where the street splits into two on either side of this kind of pie-shaped building. And I recommend art students try sketching buildings in not just from photos, but from direct observation in front of their house or in a downtown area. And when people are kind of new to this at first, they're nervous of working in public, but then when you've done it a few times, then you realize that nobody really cares what you're doing, and they're more likely to ignore you because they've just got places to go than to actually inquire about what you're doing. But typically if the people stop to see what you're doing and say hi, they're generally very supportive. They just go, "Oh, that's really cool. What are you doing?" So I would say don't be nervous about drawing in directly from observation in public, because it's a good exercise in studying the world around you and trying to represent it. So my challenge when I was drawing this sketch was to make sure that these lines here all converge at a vanishing point somewhere far down to the left, because I didn't have this situated on top of a larger piece of paper with a huge ruler making sure that the vanishing points all worked correctly. So I just basically eyeballed it in pen, drawing directly with pen, and then I went in and colored it later in marker back at the hostel that I was staying at. And then for the purposes of this lecture, I've gone ahead and added some perspective lines mapping how this image is constructed. And the vertical lines remain all parallel to each other. If you look at all the green lines, they're totally parallel to each other on the image, keeping in line, no pun intended, with the rules of perspective, 2-point perspective. But then the orange lines and the purple lines definitely converge at vanishing points. One is down here and the other is way off to the left. Okay, 3-point perspective, adding another dimension to how we are representing objects and making them increasingly more realistic. in this image, in this convention, we start to have even more implication of three-dimensional space because you have diagonal lines that are converging this way, and you have the the vertical lines that formerly were orthographic, meaning parallel and perpendicular to the picture plane, but now they are diagonal as well because they recede at a point way down at the bottom at a third vanishing point. But the viewer is meant to imagine that if they were in this space and looking at these objects, they still have square edges and corners that are each 90 degrees, but because of the way that we've represented them from this angle, they have this distortion where there are no 90-degree angles visually represented as an image. So I hope that makes sense. We're saying that these objects are boxes, but when we represent them in three-point perspective, they don't have 90-degree angles in the image themselves, in the image itself. Okay. This is a good example of M.C. Escher's mastery of drawing perspective. He is a very accomplished Dutch artist, and he's created this amazing image called Ascending and Descending in Three-Point Perspective. And he's applied some visual trickery because you have these guys that are forever going down a set of stairs and forever going up the same set of stairs, which is a physically impossible space. Yet, because of the way that he's rendered everything, and there's a very consistent relationship of light hitting this entire object from up here, cascading down here, and there's some cast shadows. This appears at first glance to be a believable object, but it's not. And I think it has something to do with the fact that the stairs on the back only are large enough to occupy 3 guys, but the ones in the front, which appear to be the same width because you assume these are 90-degree corners, but there's like 1, 2, 3, 4, 5, 6 guys going down this set of stairs. So there's some visual trickery that he's applied here to make this impossible space. That being said, overall the image follows the rules of three-point perspective. As we can see here, you have diagonal lines that are the orange one's going this way and the purple one's going to a vanishing point way off the picture plane on the upper left, and then the verticals are converging at a third vanishing point way down below the image. And here I've gone ahead and extended them even further so you can see how far they are off the image. Okay, these rules are just a guideline. Our eyes are curved just like the lens of a set of glasses or binoculars and cameras, and so we don't really perceive straight lines, even though there are objects in an image like this, like these poles and the ceiling. We understand them to be straight objects, but because they pass through a curved lens of our eye, they all become curves. And objects in the real world are all kind of placed at different angles to each other, so the number of vanishing points in the real world is infinite. Pop quiz time. Analyze the following images and decide if they're presented in 1, 2, or 3-point perspective. perspective. First image, and at any point you can pause this video if you want to look at it and break these down further. This image, I'm going to say, is basically 1-point perspective because it's fairly simple, and you have all these edges of mechanical elements that are all converging to a point somewhere here, including the Millennium Falcon is all converging somewhere in this direction. You could possibly take these elements here and imagine that they might link up to a vanishing somewhere off to the left, but in general this appears to follow the rules of 1-point perspective. In this image, this image is a 2-point perspective, which is the convention for presenting interior spaces in architectural rendering. And we're going to say that this is 2-point perspective primarily because all the vertical lines are orthographic. They're parallel to the left and right sides of the picture plane. But everything else is, all the diagonals all converge at 2 vanishing points. So the orange lines here all converge to a vanishing point over here, and then the purple ones show the ceiling, this edge of the ceiling, and then the end of the room beyond this wall, because this drawing has some kind of transparency applied to it. And then you have the rug and some kind of grid lines that the artist has applied here. They all converge to a vanishing point far off to the right hand side, and as I said, the verticals all remain straight up and down. Next image, 1-point perspective. Next image, 3-point perspective. How do we know this? Well, there are some vertical lines, right? This line appears to be fairly orthographic, like 90 degrees to the horizon line. But if you look at the edges of this building, or edges of this building, the farther they are from the center, then the more tilted to the right or to the left that they get, right? So within this space, these objects you assume are going to be parallel to each other, but as an image, they are presented not parallel to each other. They converge at a vanishing point in the bottom past the bottom of the image. So this is a bird's eye view looking down, and then you have these diagonal elements from the courtyard and the edges of these buildings that are converging to the upper right, and diagonals going this way from the bottom left to the bottom right to the upper left, like so. 1-point perspective, similar to that image of the Matrix Revolutions in this screenshot of Stanley Kubrick's The Shining. We have a lot of vertical lines that have a little bit of curve to them, but for the most part they are fairly straight up and down, and the edges of this hallway all lead our eye to these freaky twin ghosts that are at the end of the hallway. So this is an image that we can consider to be 1-point perspective. Thank you. I hope you liked it. You're now ready to draw perspective. Thanks for watching.